For 5 seconds on July 12th, flames lit up the night sky on Edwards-Lumen Ridge. That's when the Air Force Research Laboratory's Propulsion Directorate, Detachment 7, conducted part of a new phase of upper stage engine technology program testing. The current phase of the program involves testing a turbopump, the component that essentially drives a liquid rocket engine.
USET is primarily focused on the next generation of design tools. We have developed a set of design tools for the engine system, combustion chamber, and turbopump. And with that, the next generation of designers will be able to design a new rocket engine, and it will take them less time, higher fidelity, and lower cost. Back when they designed the current engine that was done in the 60s, it was a test-driven development. It took 700 tests in order for the engine to be brought to flight. And that's a tremendous amount of cost. Today we're looking at using more computer simulation and computer modeling with physics-based tools so that we can actually look at all the bad designs on the computer, try them all out, and then only come to the test stand with a finished final design for qualification testing, and then certify the reliability of the successful design.
Along with releasing hydrogen exhaust in the form of flames from flare stacks, an enormous amount of data was obtained as a result of the USET program's testing.
This is the second in a series of the exact same test, just to prove precision and that we get the same result every time, and they were very successful. The pump performed exactly as the model predicted, and it performed exactly as it did last time. So we feel comfortable going into the sustained duration tests that we've got the modeling and sim that we need, we've got the instrumentation down, and we're prepared to collect that extended time data.
Operating at 90,000 rotations per minute, this particular turbopump ran at 3 times the speed of other upper stage engine pumps, propelling the turbopump into its next phase of testing, called the mapping phase.
We just completed our characterization testing, basically doing small bumps up to 100% speed, and now we're in the turbopump mapping phase. And this is part of the program where we're validating our tools that were used to design this turbopump. So we want to see, do our computer models, when we predict a test, do they actually compare to what reality is? That way we can validate it and say the physics in the models are functioning correctly and therefore can be used successfully for future programs.
The next phase of USET testing will involve the combustion chamber. Jet Fabara, Edwards Air Force Base, California.